The last word problem for the review says that a 2.5 piece of iron has a specific heat of 481 joules per kilogram per degree Celsius and a latent heat of fusion of 3.3 times 10 to the 4 joules per kilogram. Part A, how much heat is required to increase the temperature of the piece of iron from 30 degrees Celsius to 1,540 degrees Celsius. And part B, how much heat is required to completely melt the iron. Okay, so go ahead and pause, try to solve this, and when you're ready, unpause. Right, so let's write down the givens. We have 2.5 kilograms, that's a mass, and 481 joules per kilogram per degree Celsius, that's a specific heat. And you have 3.3 times 10 to the 4 joules per kilogram, that's a latent heat. And you have 30 degrees Celsius, that's the temperature. And you have 1540 degrees Celsius, that's another temperature. And we want to find, let's see here, a heat Q for part A. And for part B, we want to find another heat again. So let's see what's happening here. So you have a piece of iron, and it's initially at 30 degrees Celsius. So this is going to be the initial temperature of iron is 30, and then you're going to add some heat to it, Q, and you're going to increase the temperature of the iron to the point where it's about to melt, so right before it melts. And at the temperature where it begins to melt, that's going to be the final temperature, which is going to be 1540. So this is going to be the final temperature of the iron. So for part A, we want to figure out how much heat is going to take to increase the temperature of the iron. So here, the equation is going to be so here, this is the iron stays solid in both cases, so this is a constant phase. So in this case, the heat is going to be equal to mass of iron, specific heat of iron, multiplied by final temperature of iron, minus initial temperature of the iron. So then here, you just plug in the mass of iron is going to be 2.5. The specific heat of iron is 481. The final temperature of the iron is 1540. And the initial temperature of the iron is 30. So that should give you, let's see here, about 1,000,000 joules of heat. So 1.82 times 10 to the 6 joules, or 2,000,000 joules. So that's how much heat it takes to heat up iron to the point where it just is right before it starts to melt. Now, once the iron is hot enough, it's going to start to melt. And so you're going to have, so this is for part B, you're going to have partially solid and partially liquid iron, so a mix between two states. And so for part B, we want to figure out, so if you have iron that begins to melt, how much heat that you have to input so that it completely melts and becomes just a molten iron. So in this case, the heat is defined by the mass of the iron multiplied by the latent heat of fusion. And we're going to assume that we're going to melt all the iron. So in this case here, then the heat is going to be the mass of the iron, which is going to be 2.5 multiplied by the latent heat of fusion, which is going to be 3.3 times 10 to the 4. And this will be equal to 8.25 times 10 to the 4 joules to completely melt the iron.